Okay, so the last thing that I notice here is essentially the borders. When we disable this whole thing here, the borders of this guy are all wavy gravy here, and that's no good. What we need is for the wall to have the original straight borders that it had before. So let's go over to the border, and we can basically say the closer these points, the closer you are for every point, for closer you are to the edge of the wall, apply the noise less. So to do that, let's go all the way back here where we first defined these borders. I'm going to go into primitive selection mode. Just select them all, I guess, and then control select the ones in the middle. So now we just have the borders. So I'm going to make a group, and the group will be called borders. And that group is going to propagate all the way down through all the madness that we end up doing. The Voronoi, the other Voronoi, the Bricker, and all that jazz. And by the time it gets over here, like this, we'll still have the group, but the group will now consist of many more polygons because they've all been sliced and diced up. Let's just keep getting turned back on. So to show you that, I'll make a delete. I'll put this guy here, and I'll say, hey, this isolate just the borders. And sure enough, there it is, just the borders. Cool. So with that information in mind, I'm going to say all the way down here, let's just attribute create a thing called border. Only make it where on the border points, the points that are in the borders primitive group, and write a 1 to it. So we'll call this like border adder. So that should make sense so far, but here's where it gets a little silly. Let's actually say attribute transfer. Let's do a transfer from itself and to itself, but we're only going to source it from one part of it. Let's just source it from the border, that border attribute we just made, and then we'll write it basically out to everywhere, but they're only allowed to draw it from that one place where it's been set to 1 in the first place. So check this out. If I say 0 here, it won't really have anywhere to look to find it, because that's the distance that each point is allowed to look to find that attribute. Or let me make it a little easier to visualize, literally. We'll put a point wrangler here, and we'll say, make the color be that. So we'll say, make it be border, border, border. So basically we're making a color vector out of the same flow 3 times. And we have black for everything and white just where the border is. Now that would be true even before we did the attribute transfer, because we only applied the 1 value to the group borders. Come back here again. I put the distance threshold to 0. If I made it higher, you can see immediately it starts to pop up. But the higher I make this, the farther that will go. I want it to go 0, but instead I'll want it to like blend in. So we get this kind of graded look like that. And that's really great. You can already see where this is going. Where it's white, we won't have the noise applied, and where it's black, we will. Now, of course, this is way too high. So how about something like 0.05? Maybe that's good. Let's just, that seems about what I expect. Cool. And let's call this viz border. And actually, this whole thing should be done before this. It's this thing that we're actually trying to prevent. So I'm going to say, now that we've calculated it, here we are doing that noise. Probably shouldn't have actually deleted that whole business out there earlier. So let's go grab that back from the small noise thing. I essentially just want to say, you know, let's just go back in here and do it ourselves. We want to grab that value with a bind. We'll say bind, border, to bring it in. We'll flip it. We'll do a complement. That way, where 1 becomes 0 and 0 becomes 1, because it's this black area that we want to actually do it. And we'll say, how about we multiply this whole thing, whatever the noise vector it is that we got from this turbulence noise, multiply times that. Oops, looks like we replaced it. I want to multiply it like that. There we go. And you can see it's gone. Now hopefully the interior is still moved though. So let's turn off our visualization thing here. We don't need to see that anymore. Smooth wire shaded, and sure enough, our inside is still all swirly and whirly, but the outside is now straight. Wonderful. We got our normals. We're all good. I'm going to say, let's take our actual piece isolation and let's do that after all this is done. Like that. Now we can look at it. We can say there's a piece and there's a piece. I'm pressing space G to go to these pieces. So we got all these interesting looking pieces now. And we're not simulating with them. We simulated with the, if we go back over to, basically if we just go to its neighboring thing here, this is what the piece used to look like. Nice and simple. This is what the piece looks like now. Nice and complicated. That's what we want. It's gonna render a lot better. It's gonna look a lot more convincing to anybody who's watching. Let's go ahead and write these instance highs out now. Save them all out. See, it takes a little bit longer because there's a lot more geometry to write, but still overall not too shabby. So we changed the path here to incorporate this instances high thing. I'm going to go all the way down here for these instance paths. Let's kind of add that in here, where I have an instance low, and let's make an instance high. You could, of course, even have separate control panel things for the low versus the high. Instance high will be this instances, that's JI, high business. There we go. That shouldn't affect anything because we're not even using that attribute yet. But it's there. So we can check that, of course. So we have the instances low, instances high. And now, if I go, let's say I go to some frame, okay? So it's still using the low stuff. I'm going to go to some frame like 61. We got all this crazy madness going on. Really making my computer chug. Not using that much memory, but still, it's still a CPU intensive thing to draw all this. And it's about to get more intensive once I change it to the high stuff. So I'm just going to say, hey, instance guy, let's give you a little brother over here, right next to it. Make a switch, and the switch will switch between the low resolution and the high resolution. So I'll say like instance low, instance high. We could put this also on the control panel if we wanted, but suffice to say, I'm going to switch over to the high one here, and the high one will use the high attribute. And you can see it's loading it all, and now it's probably stamping it all. And if my computer was faster, this would be done by now. This is, of course, the kind of thing where normally we're not going to view the high resolution in the viewport, but I do want you to see it now. And there it is. Now we've got all this craggly looking pieces. It's all ground up and detailed and cool looking. I go back to the first frame. It'll still look like a solid box. This is the kind of thing that at render time, we'll just let it render with the high pieces. We're not normally going to look at these high pieces here in our viewport. But again, just to demonstrate that they are working, let's just go back to the first frame. So I have to say let's go back to the first frame real quick, but it's clearly anything but. And there you go. We have a solid box. Everything's in its right place. Everything works. And that's what's so powerful about being able to sim with the proxy geometry and then skip over to the high res.